This video is for Section 5.2 Probability Rules. So the first thing we're going to talk about is sample space, and so this is a set of all possible outcomes for a given process. A probability model is a description of some chance process that consists of two parts, a sample space, which we call S, and a probability for each outcome. And an event is any collection of outcomes from some chance process or a subset of the sample spaces. They are usually designed or designated by a capital letter. So the first example we will look at is the probability of rolling a die. So many board games involve rolling dice. Imagine rolling two fair six-sided dice, one that's red and one that's green. So the problem is, give a probability model for this chance process. So if we think about it, if we have two dice or die, one that's red and one that's green, your outcomes for the red die would be 1, 2, 3, 4, 5, and 6. Your outcomes for the green die would be 1, 2, 3, 4, 5, and 6. So basically what you could have is you could have one die where you rolled a red or a 1, and on the green die you could roll another 1. You could have 1 for a red and 2 for a green, 1 for a red and 3 for the green, 1 for a red and 4 for the green, a 1 for the red, a 5 for the green, a 1 for a red, and the 6 for the green. And so if you think about it, this same process would repeat for each of these numbers. So like I could have a 2 for a red and a 1 for a green, and a 2 for a red and a 2 for a green, and a 2 for a red and a 3 for a green. And this would continue on and on each time. So if you think about it, there are 6 numbers here, or 6 different options here. And I would have that for the 3 column, the 4 column, the 5 column, and the 6 column. So basically I would have 6 for if the 2 was a red, 6 for if the 2 was a, or if the red was a 3, 6 for if the red was a 4, 6 for if the red was a 5, and 6 for if the red was a 6. So if I add all of those chance possibilities up, I would say 6 plus 6, 12, plus another 6, 18, plus another 6, 24, plus another 6, 30, plus another 6, 36. So in all total, there are 36 different possibilities here. You could have also gotten this by saying, okay, there's 6 possibilities for red, and there is 6 possibilities for green. And so by taking those and multiplying those together, I would get a total of 36 possibilities. Alright, so to use our previous example about the die, for number 1 we have to find the probability of the sum of 5. So if we think about 5, we could say, okay, if we had a red that was a 1, plus a green that was a 4, that would be that would add up to give me 5. I could also have a red that was a 2, plus a green that was a 3, that would add up to give me 5. I could have a red that was a 3, plus a green that was a 2, and that would also give me 5. Or I could have a red that was a 1, plus a green that was a 1. And so if I think about this, I've done both colors. So like the order doesn't really matter. So as long as I have in the numbers like 1 and 4, as long as I have a red that's a 1 and a green that's a 4, when I flip them, I deal with that. So I deal with all the color possibilities that I could have. So then basically what you have to say is, okay, what is the probability that I would get a 1 plus a 4? So if you think about it, total we had 36 possibilities. And so of those 36 possibilities, there's only one time that is a 1 plus 4. So the probability that you get a 1 plus a 4, with the red being 1 and the 4 being green, you only have a 1 out of 36 chance that that happens. The probability that you get a 2 that's a red plus a 3 that's a green would also be 1 out of 36. So it only happens 1 out of 36 times. The probability that you get a 3 that's a red plus a 2 that's a green, that would only happen also 1 out of 36 times. And the probability that you get a 4 that's a red plus a 1 that's a green would also just happen 1 out of 36 times. So we add all of these together, and we see 1 out of 36 plus 1 out of 36 plus 1 out of 36 plus 1 out of 36. We add together the top number, so 1 plus 1 plus 1 plus 1 to get 4, and we keep the bottom number 36. So the probability that you get a sum of 5 is 4 out of 36. All right, the probability of rolling a sum of at least 8. So if I'm thinking about at least 8, that would be 8, 9, 10, 11, or 12. So if I'm thinking about 8, I could say, can't do 1 and 7 because I can't roll a 7 on a 6-sided die. I could do a 2 and a 6. I could do a 3 and a 5. I could do a 4 and a 4. I could do a 5 that's red, and then a green 3, and I could do a 6 that was red, and a green 2. To get a 9, I can't do a 1 because I can't roll an 8. I can't do a 2 because I can't roll a 7. But I could do a 3 because I could roll a 6. And I could do a 4 because I could roll a 5. A 5 because I could roll a 4. And then a 6 because I could roll a 3. For 10, I can't do 1 and 9. Can't do 2 and 8, can't do 3 and 7, but I could do 4 and 6. I can do 5 and 5, and I can do 6 and 4. To get 11, I can't do 1 and 10, I can't do 2 and 9, I can't do 3 and 8. I can't do 4 and 7. I can do 6 and then 5. Or I could do 5 and then 6. So if I wanted the probability that I got a sum of at least 8, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 out of 36. But because I can reduce that by dividing the top and the bottom both by 2, then I would get 7 over 18. For 3, it says probability of no 6s. So if I wanted the probability of no 6s, then that would mean that I rolled a 1, a 2, a 3, a 4, or a 5. Basically, I rolled a 1 through 12 without rolling 6s. So I can't roll a 1. So really it's a 2 through 12 because I have to roll both the die. I'm not going to get one that doesn't have anything on it. So if I roll a 2, obviously that's going to be a 1 and a 1. Or I could switch it. Really doesn't matter. All right, if I roll a 3, it'd be a 1 and a 2. If I roll a 4, it could be a 1 and a 3, a 2 and a 2, or a 3 and a 1. To roll a 5, a 1 and a 4, a 2 and a 3, or a 3 and a 2. 6, 1 and 5, 2 and 4, 3 and 3, 4 and 2, 5 and 1. 7. I can't do a 1 and a 6 because I can't roll any 6s, but I could do a 2 and a 5, 3 and 4, 4 and 3, 5 and 2. For 8, I can't do 1 and 7. I can't do 2 and 6. But I could do 3 and 5. 4 and 4. 5 and 3. For 9, 1 and 8's out, 2 and 7's out, 3 and 6 is out, 4 and 5 is not, and 5 and 4 is not. For 10, I can't do 1 and 9, can't do 2 and 8, can't do 3 and 7, can't do 4 and 6, but I can do 5 and 5. And for 11, it would be 6 and 5, but I can't use any 6s. And for 12, it would be 6 and 6, and I can't use any 6s. So that's all. So then I would count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 out of 36. 4 is probability of at least 1 3. So if I am thinking about 3s, 1s would be out, 2s would be out, 3s would be out. In 4s, I could do a 1 and a 3. 2, 2 would be out, but 3 and 1 would be okay. For 5, 1 and 4 would be out, 2 and 3 would be okay. And 3 and 2 would be okay. For 6s, 1 and 5 is out, 2 and 4 is out, 3 and 3 is good. For 7s, 2 and 5 is out, 3 and 4 is good. And 4 and 3 is good. 5 and 2 is out. 4, 8, 3, and 5 is good. 5 and 3 is good. 4 nines, remember in our nines that we would have had 6 and 3 and 3 and 6, and for this one we had to leave out the 6s, but those would still work. So 6 and 3 and 3 and 6. For 10s, 3 would be paired with 7, and that's not going to work because I can't roll a 7. For 11s, 3 would be paired with 8, and I can't roll an 8. For 12s, 3 would be paired with 9, and I can't roll a 9. So these are all my at least 1 3s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 out of 36. Not a sum of 5. So that one's good. Good, 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 good. Everything but a 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Remember that for 10s, we could have also had 6 and 4, 4 and 6. For 11s, we could have also had 6 and 5, 5 and 6. And for 12s, we could have had 6 and 6. So, not a sum of 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 out of 36. Mutually exclusive. So that means that two events that have no outcomes in common and thus can never occur together. So for any event A, 0 is less than or equal to probability of A less than or equal to 1. If S is a sample space in a probability model, probability of S equals 1. In the case of equally likely outcomes, the probability of A equals the number of outcomes corresponding to event A over the total number of outcomes in the sample space. The complement rule means basically anything that is not A, so you can find the probability of A, this little c means complement, and that would be 1 minus the probability of A. Addition rule for mutually exclusive events: if A and B are mutually exclusive, which means that they can't happen at the same time, the probability of having an A or a B is probability of A plus the probability of B. So an OR is always going to be an AND. So an example on distance learning. So distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking a distance learning course for credit and record the student's age. Here's the probability model. So in our probability model, we see 18 to 23 is a probability of 0.57, 24 to 29 is 0.17, 30 to 39 is 0.14, and 40 or older is 0.12. So the problem is, A, show that this is a legitimate probability model. So for A, the probability of each outcome is a number that's between 0 and 1. So if we look at all of these, they're all a probability that's between 0 and 1. And all of the probabilities of the possible outcomes add up to 1. So what we could do is we could add all of these together, and we would see, if we did that, 0.57 plus 0.17 plus 0.14 plus 0.12 all adds up to give us 1. And so because all are less than all of them are less than 1, each one of those, they all add to 1, and they're between 0 and 1, so like they're all positive, then we would say that this is a legitimate probability model. So for B, it says find the probability that the chosen student is not in the traditional college age group, 18 to 23. So what we can do for that is we can say, okay, we know that the whole is going to be 1, so we could subtract out the probability that you are in the 18 to 23 group. So if we do that, we know that the probability that you're in the 18 to 23 group is 0.57. So we can basically say 1 minus 0.57 is going to equal 0.43. So what that means is that 43% are not traditional college students. Check your understanding. Choose an American adult at random. Define 2 events. So A equals the person that has a cholesterol level of 240 milligrams per deciliter of blood or above, high cholesterol. B is a person has a cholesterol level of 200 to 239 milligrams per deciliter, borderline high cholesterol. According to the American Heart Association, the probability of A is 0.16. The probability of B is 0.29. So this means that the probability that you have a high cholesterol level or above is 0.16 and borderline is 0.29. So number 1 says explain why events A and B are mutually exclusive. So for number 1, we can say that these 2 events are mutually exclusive because a person cannot have a person cannot have a cholesterol level of both 240 or above and between 200 and 239 at the same time. So we know that A is going to be greater than or equal to 240, and you obviously cannot be less than or like 200 to 239 if you are in B. So these 2 are mutually exclusive because you can't be in both parts at one time. Say in plain language what the event A or B is. So basically, what is the probability of A or B? So what this means is that you basically have what is the probability that a person has either a cholesterol level of 240 or up, or a cholesterol level between 200 and 239. So the way that we would find that probability of A or B would be to add those together. So 0.16 plus 0.29. And whenever you do that, you get 0.45. 3 says if C is the event that the person chosen has a normal cholesterol, so that's below 200 milligrams per deciliter, what's the probability of C? Alright, so to find the probability of C, you would basically say that altogether you know that it's going to have a probability of 1, A, B, or C, because you either have high cholesterol, borderline high, or you are normal. And so all of those together would equal 1, and we would subtract out the probability that you have A or B. So this is subtracting, you either have high or you're borderline. So that would be 1 minus 0.45, and that would be 0.55. So the probability that you have a normal cholesterol would be 0.55. Two-way table probabilities. So students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had a pierced ear, for all 178 people in the class. The two-way table below displays the data. So in the table, you can see gender, and you can also see if the people had their ears pierced or not. And then you can see the numbers, of course, for each gender and whether they had their ears pierced or they did not. So the problem says, suppose we choose a student from the class at random, find the probability that the student has A, pierced ears, B is a male with pierced ears, or C is a male or has pierced ears. So for A, we know that there's a total of 178 people. And so the way that we would find the probability of pierced ears is we would say the total is 103 over the total for pierced ears for yes is 103 over the total of the entire table, which is 178. All right, so the probability that a male has pierced ears, we would go to the males in the table that have pierced ears, which is 19, over the total number that we have, which is 178. And so this time we're worried about if you're a male or you have pierced ears. So what we would need to do for that is that's going to be the probability of like A being male or B being having pierced ears. So what we would do is we would say the probability that you are a male, there are 90 out of 178 people that are male, plus the probability that you have pierced ears, which is 103. Out of 178. When we add those together, that gives us 193 over 178. But that can't be true, because if you think about it, 193 is way bigger than 178, which would mean that this whole thing would be bigger than 1. The reason that is because if you think about it, you double counted those males that had pierced ears, because you counted them in the total males, but you also counted them in the people that had their ears pierced. So what you have to do is you have to subtract out the males that have pierced ears, which is that 19 out of 178. So whenever you do that, you would say 193 minus 19 to get 174. So you would have 174 out of 178. Now the reason that for this one we had to do things a little bit differently because it was an or, we usually just add them together. But these two events are not mutually exclusive. So what that means is you could be a male with pierced ears. To be mutually exclusive, it would be like two things that are not possible at the same time. So like being a male and being a female, not possible at the same time. So you would have to subtract out the people that you counted twice. So the general addition rule for two events. So if A and B are two events resulting from some chance process, then the probability of A or B would be probability of A plus probability of B minus the probability of A and B at the same time. So this is when they're not mutually exclusive. So, check your understanding. A standard deck of playing cards with jokers removed consists of 52 cards and 4 suits, clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominations ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. The jack, queen, and king are referred to as face cards. Imagine that when we shuffle the deck thoroughly and we deal 1 card, let's define events A as getting a face card and B getting a heart. So for number 1, the first thing it asks us to do is to make a two-way table that displays the sample space. Alright, so if we're making a two-way table, the 2 pieces of information that we are worried about is getting a face card and getting a heart. So, the way that you get a heart is you either get a heart or you get not a heart. The way that you get a face card is you either get a face or you get no face. So, remember that for each of the suits, you have 13 cards. And so, of those 13 cards, there are 3 that have a face, a jack, queen, and king. So that would be 3 here. And, of course, since there are 13 total, there would be 10 that had no face. Alright, if you're thinking about your face cards in general, because there are 4 different suits, your clubs, diamonds, hearts, and spades, then that would mean that there were 12 different face cards, because of course each of those has 3 face cards. So if we know that there are 3 that are face cards that are hearts, then that would mean that there are 9 that are face cards that are not hearts. And in talking about everything, we talk about that there are 52 cards total. And if we want those that have no face and not a heart, then we would have 30. The reason we would have 30 is because, of course, there would be sorry, I got distracted. Okay, there are 52 cards in total, and to be not a heart and not a face, think about the ones that are faces. So, of course, you have 12 that would have a face, so that would be 52 minus 12, which would get you to 40. And then you want to get rid of the ones that are not hearts, so you would subtract 10 from that to get your 30. Or subtract 10 that are hearts, and that would give you 30. For number 2, it says probability, find the probability of A and B at the same time. So the probability of A would be the probability that you got a face card that was also a heart. So by looking at that, you would say, okay, the ones that are heart cards that are also face cards would be 3 out of 52. Actually, this part right here may not be like completely accurate. It's probably not a very good way to write that, even though we usually say and is plus, just because we've been using that for or. So what we would basically do is just look at our two-way table that we created here, and we would say, okay, we know that there are 3 heart cards that are also face cards out of the total, which is 52. 3 says, explain why the probability of A or B is not equal to the probability of A plus B, and then use the general addition rule to find the probability of A or B. So the reason that we can't say the probability of A or B is equal to the probability of A plus the probability of B is because you could have a heart card that was also a face card. So those two things are not mutually exclusive. So probability of A and probability of B are not mutually exclusive. That means that they can happen at the same time. Another way that you might hear that is you might hear it called disjoint. The way that you would find the probability of A or B is by saying the probability of A plus the probability of B and subtract out when you have A and B at the same time. So we know that the probability of A is the probability that you get a face card. And so we know that there are 12 out of 52 cards that are face cards. We know the probability of getting a heart is going to be 13 out of 52 because out of the 52 cards, 13 of them are hearts. And we know that the probability of being a heart and a face is 3 out of 52. So basically what we need to do is we say 12 plus 13, 25, minus 3, 22. And so we would get 22 out of 52 as being either a heart or a face card. And you could say 22 out of 52 is the same thing as 0.42. Venn diagrams. So you are probably familiar with Venn diagrams because you start them very, very early in your math career. One thing that you probably don't talk a whole lot about is the notation that we use for that. And so what we do is we let this U sort of shape be or, and we let this upside down U shape be and. And so one way that you might can remember that is I could connect this over to make an O, and I could connect this across and make an A for and. So probability of A and B would be the stuff that was in the middle, so where they overlapped. And the probability that it's A or B is anything that's in the A circle and anything that's in the B circle. A complement or A prime means A complement or not A. So for this example, we're going to kind of put everything together. So in an apartment complex, 40% of the residents read the USA Today, only 25% read the New York Times, 5% of residents read both the papers. Suppose we select a resident of the apartment complex at random and record which of the two papers the person reads. So A asks us to make a two-way table that displays the sample space of this chance process. So let's let A be those who read the USA Today. So this is USA Today. And let's let B be the New York Times. So what that means is the probability of A is those who read the USA Today, which is 40%. 0.40. And the probability of B is those who read the New York Times, which is 25%, so 0.25. And then, of course, the probability that they read A and B, so that would be both of them, would be 5%, so 0.05. So for A, it asks us to make a two-way table, which means that we are going to have one section that reads the New York Times, and then we're going to have another section across the top that reads USA Today. in each of those, we would have a yes, they read, and a no, they don't, and then, of course, a total. So, yes, they read New York Times. No, they don't. Total. So, it's easiest to start with the ones that we know for absolute certain. So, we know that 40% of the residents read the USA Today. So, in the yes column for USA Today, I'm going to put 40. And that's really 40%. So, it might be helpful to do 40%. Now, if there's 40% that read the USA Today, that means there's 60% who do not. And then the reason that that is because our total should be 100%. All right, another thing that we know for absolute definite is only 25% read the New York Times. So in my New York Times, in my yes row, I need 25 or 25%. That means that reads the New York Times for no. In that row, I would have 75 or 75% for my total because I know in this column, I need that to add up to be 100. And so if this was 25, this would have to be 75 to add up to be 100. All right, the next thing that I can tell. Probability of A is the USA Today. So we already said that that was 40% in my yes column. Probability of B is New York Times is 0.25. So I know that that's yes, 0.25. Probability of A and B, so that means that they read the New York Times and the USA Today is 0.05 or 5%. And so if in the yes, I have 5. Then in the no yes, I would have 35. Because my total USA Today has to add up to give me 40. And I know if there's already 5 there, then what's missing is 35. So now because I filled in the New York Times no, but the USA Today yes, I can figure out no for New York Times and no for USA Today because I know that no altogether has to be 75. So that means that this has to be 40 or 40% for my no. And for my yes no, because this is 40 and the total no is 60, then that has to be 20. So you kind of have to work backwards a little bit. Start with the stuff that you absolutely know and then fill in what you can figure out from that information. For B, it asks us to construct a Venn diagram to represent the outcomes of this chance process. So for a Venn diagram, I'm going to have my 2 circles that overlap in the middle. And we'll let the first circle be A. And we know that A is the USA Today. And for the second circle, we'll let it be B, which is the New York Times. In the middle, I know that I'm going to have 5 because that represents A and B. So the middle is where A and B overlap. Now I know that all the probability of A is 40. And so because in the middle I have 5, that means that A must be 35. And for my B, I know that my B is 25 or 0.25. And so if in the middle I have 5, then that means that B by itself has to be 20. All right, for C, it asks us to find the probability that the person reads at least one of the papers. So that would be the probability that they read A or they read B. That would be anything that was in the A and anything that was in the B. What that would mean is I would find the probability of A plus the probability of B, and I would subtract out where they overlap in the middle. So the probability of A is 0.4 plus the probability of B, which is 0.25, and I need to subtract out 0.05. So when I do that, I get 0.60. If I were using the Venn diagram, I could say, okay, I'm going to add them all together. 35 plus 5 is 40, and 40 plus 20 is 60, because this would mean A or B, anything that was in the A circle, anything that was in the B circle. So if I add up all the individual parts, I would get 0.60. D asks us to find the probability that the person doesn't read either paper. So if I was finding the complement, this would look like probability of A complement and B complement. So if I'm thinking about this, this would be anybody that was not in the A circle or in the B circle. Well, all together, I usually draw Venn diagrams with a big box. The big box represents everybody. The stuff in the circle represents everybody that falls into one of the categories. So if I'm thinking about this, the big box, everything inside the box would represent 100%. But in my circles, I only represented 60%. That would mean that anybody that did not fall into one of these circles would be in the 40%. And so the answer for A complement and B complement would be 40% or 0.40.